Good evening, everyone. So today in this lecture, we'll be discussing more about the Coulombs law, vector form of Coulombs law, and we'll be discussing about the superposition of different forces, particularly the superposition principle. When n number of charges are interacting with each other, then how do we calculate the charge acting on a single charge, force acting on a single charge? So in the last class, what we discussed was that suppose we have charge q1 and q2 here, and both these charges are separated by a distance r, and they're placed in a medium, and the medium is air or vacuum. Medium is vacuum. If these two charges are placed in a vacuum which are separated by a distance r, then the force between them, electrostatic force between them, is given by the Coulomb's law, that is 1 upon 4 pi epsilon naught q1 q2 upon r squared, where epsilon naught is nothing, it's the permittivity of free space. Permittivity of free space. ये हमारे पास क्या है? एप्सिलॉन नॉट इज द परमिटिविटी ऑफ फ्री स्पेस. सपोज कि ये चार्ज Q1 एंड Q2 स्पेस में नहीं है, किसी मीडियम में. लेट्स सपोज these charges are placed in some medium. इन चार्ज को किसी मीडियम में रखा गया. मीडियम कोई कुछ भी हो सकता है. मीडियम कैन बी वाटर, कैन बी ग्लास, it can be any other medium that we can place all both these charges with the same separation r. सेम सेपरेशन के साथ दोनों चार्ज को हम रखते हैं. That's the r. Now the force between them is not same. The force between them changes by this factor that we call as epsilon r. Suppose q1 q2 are two charges. They're separated by a distance, same distance r, but now they are placed in some medium. किसी मीडियम में रखा गया. The force between them is given by q1 q2 upon 4 pi epsilon naught epsilon r r square. जो epsilon r है हमारे पास, it's nothing, it's epsilon into this epsilon r is called as relative permittivity. Relative permittivity. And it is given by permittivity of medium, upon the permittivity of free space. ये हमारे पास बराबर है permittivity of medium upon the permittivity of free space. This is epsilon m upon epsilon naught, where this is the permittivity of medium and this is the permittivity of free space. Now the question is, what actually the permittivity is? How do we understand by the permittivity, this term permittivity? Permittivity measures the extent of opposition. It measures the extent of opposition offered by the medium for electric field टू एस्टेब्लिश। और हम इसको इस तरह से भी समझते हैं कि एक मीडियम कितना अमाउंट ऑफ इलेक्ट्रिक फील्ड जो है एलो करता है टू पास थ्रू इट। जितना मीडियम की परमिटिविटी ज्यादा होगी, जितनी मीडियम की परमिटिविटी ज्यादा होगी, उतना कम इलेक्ट्रिक फील्ड वो एलो करेगा टू पास थ्रू इट। या हम ये भी कह सकते हैं कि इस permittivity also defines, also explains the extent of polarization of medium or the degree of polarization of a medium। जितनी एक मीडियम की परमिटिविटी ज्यादा होगी, उतना उस मीडियम के मॉलिक्यूल जो है ज्यादा से ज्यादा पोलराइज होंगे। इट ऑल्सो signifies, permittivity also signifies the degree of polarization of a medium। जितना ज्यादा परमिटिविटी एक मीडियम की होगी, उतना ज्यादा वो पोलराइज होगा। और जितना ज्यादा एक मीडियम पोलराइज होगा, उतना ज्यादा इलेक्ट्रिक फील्ड एस्टेब्लिश होगा अपोजिट टू द डायरेक्शन ऑफ द एक्सटर्नल इलेक्ट्रिक फील्ड। जिसकी वजह से क्या होगा कि टोटल इलेक्ट्रिक फील्ड जो उस मीडियम में एग्जिस्ट कर रहा होगा, वो ओवरऑल डिक्रीज हो जाएगा। दैट विल डिक्रीज। फॉर एग्जाम्पल, हमारे पास वाटर है, वाटर इज अ मीडियम। वाटर का रिलेटिव परमिटिविटी इट्स 80। रिलेटिव परमिटिविटी वाटर का जो है दैट्स 80। इसका मतलब ये है कि सपोज, व्हाट डज इट मीन, सपोज हमारे पास दो चार्ज है Q1 और Q2। इन दोनों के बीच में सेपरेशन R है, एंड द फोर्स बिटवीन देम इज Q1 Q2 अपॉन 4 पाई एप्सिलॉन नॉट R²। अब इन्हीं दो चार्जेस को उठा के मैं किसी दूसरे मीडियम में रखता हूँ, व्हाट इज दैट मीडियम। या मैं दोनों चार्ज को उठा के वाटर में रखता हूँ, और मैं देखता हूँ कि फोर्स कितना लग रहा है बिटवीन Q1 एंड Q2। नाउ द relative permittivity of this water is given as 80, so it will be given by F dash, that's Q1 Q2 upon 4 pi epsilon naught epsilon R² यहां से हम देख सकते हैं कि Q1 Q2 अपॉन 4 pi epsilon naught into 80 into R²। So we can just conclude that जो नया फोर्स होगा between the two charges, it will decrease by 80 times। It will become 1 by 80 times of the प्रीवियस फोर्स। तो ओवरऑल क्या होता है, परमिटिविटी की वजह से, परमिटिविटी हमें ये बताती है कि कितना फोर्स दो चार्ज के बीच में लगेगा एक मीडियम में। जिस मीडियम की परमिटिविटी ज्यादा होगी, उस मीडियम में नेट फोर्स जो दो चार्ज के बीच में होगा, नेट फोर्स जो एक चार्ज पे लग रहा होगा, इट विल डिक्रीज बिकॉज ऑफ द परमिटिविटी ऑफ द मीडियम। परमिटिविटी ऑफ फ्री स्पेस क्या होती है, परमिटिविटी ऑफ एयर इज 1। That's why we write Q1 Q2 upon 4 pi epsilon naught R²। पर permittivity of water is 80। अगर यही दो चार्ज हम वाटर में प्लेस करते हैं, तो फोर्स बिटवीन द टू चार्जेस डिक्रीजेस बाय एन एक्सटेंट ऑफ 80। यानी फोर्स 1/80 टाइम्स हो जाता है, 1/80 टाइम्स ऑफ द प्रीवियस फोर्स। वी हैव अ क्वेश्चन हियर। हमारे पास एक क्वेश्चन है। Two charges Q1 and Q2 are placed in a vacuum at a distance of d, and the force acting between them is F. If a medium of dielectric constant 4 is introduced around them, the force now will be। यानी हमारे पास दो चार्ज हैं Q1 Q2, जो वैक्यूम में प्लेस किए गए थे एट अ डिस्टेंस ऑफ R, Now these two charges are placed in a medium. एक मीडियम में इनको प्लेस किया गया है. This is the medium. They have been placed in some medium. Separation between these two charges is once again R. और relative permittivity और dielectric constant जो medium का है, that's given as relative permittivity is also called as dielectric constant of a medium. That's given as 4. That's given as 4. The question is कि the force now will be इसका if the relative permittivity of a medium is 4, it means the new force will be nothing but 1 by 4 times of the previous force. So it will be F upon 4. If we talk about the permittivity of metal, we know that the extent of polarization of a metal is infinite. They are infinitely polarized, and because of which inside the metals or the conductors the electric field does not exist, or we can say the permittivity offered by the metallic metals or the conductors is infinite. So we can say the permittivity of conductors or metals is infinite. You can write it here. Permittivity of metals or conductors is infinite, because we know inside the conductors the electric field does not exist. It means the conductors show infinite resistance to the electric field to exist inside the conductor. That's why we say the permittivity of metals or conductors is infinite. Now let's try to solve this question. We have a question here. The question is, a particle of mass M carrying charge Q1 is revolving around a fixed charge minus Q2 in a circular path of radius r. And we have to calculate the time period of revolution and its speed also. The question is like this. A particle of mass M carrying charge Q. हमारे पास एक particle mass M and charge Q1 is revolving around a fixed charge. हमारे पास एक fixed charge है. It's fixed. Minus Q2. Minus Q2. This charge is fixed. और ये जो पार्टिकल मास m है और जिसका चार्ज q1 है, it will be revolving around this q2 charge is revolving around a fixed charge. So it is revolving around a fixed charge. So this fixed charge will be at the center of this circle. This fixed charge will be at the center of this circle. Here is a circle, and we have charge q2 here, minus q2 here at the center of the circle. And suppose the radius of this circle is r, and we have a charge of mass m and charge q1, and this charge q1 is revolved around the circle because of the mutual electrostatic force of attraction between q1 and minus q2. We know the force between q1 and minus q2 is nothing. It's F is equal to k q1 q2 upon r square. That's the radius of this circle, and this force is a attractive force here. So this force will be directed towards the center of this circle along the radius. The force will be given by k q1 q2 upon r square, and because of this electrostatic force, the charge Q1 is revolving around the charge Q2. So we can say that it is this electrostatic force which is providing necessary centripetal force for this Q1 charge to revolve around this charge Q2. So we can just put this KQ1 Q2 upon R square equal to the centripetal force, that's mv square upon R. R is the radius of this circle. R and R will be left with. And we have to calculate the period of revolution and its speed also. So we have to find the speed. Speed will be V square, that will be K Q1 Q2 upon 4 pi epsilon naught R multiplied by the mass of this charge. So we'll be taking root of this. So we'll be left with Q1 Q2 upon 4 pi epsilon naught R multiplied by the mass of this particle. So this is the velocity with which, or the speed with which this particle must be moving. This particle must be moving around the charge Q2. Now, the question is asking to calculate the time period. To calculate the time period. So time period will be nothing. The total circumference traveled by this charge, that is 2 pi r upon the velocity. Upon the velocity. So 2 pi r upon velocity or the speed. It's not the velocity, it is speed. So value of v is nothing. It came out to be q1 q2 upon 4 pi epsilon naught r into m. So this will be the time period. This will be the time period of this charge. So now let's discuss about the vector form of Coulombs law. We know force is a vector, and vector always has a magnitude as well as direction. We need to define both magnitude as well as direction of a vector. And one of the important point of Coulomb's law is that the electrostatic force of repulsion or the electrostatic force of attraction between the 2 point charges is directed along the line joining the two charges. It's always directed along the line joining the two charges. Suppose we have two charges Q1 and Q2 here, and they are separated by a distance R. The force on Q2 will be because of 1, so we'll write it F21. And the force on Q1 will be because of 2, we'll write it F12. So this force is directed along the line. This force is directed along the line joining the two charges. ये force जो है F21, that's the force on 2 because of charge 1, and F12, that is the force on 1 because of the charge 2. It's always directed along the line joining the two charges. So that's how the direction of force is calculated. We know that electrostatic force of attraction between the two charges is a mutual force of attraction or the mutual force of repulsion. If we take these two charges Q1 and Q2 as a system, they have only the internal force of interaction. That's the electrostatic force. Internal force of interaction. That's the electrostatic force of interaction. The charge Q1, suppose that charge Q1 is a positively charged and charge Q2 is negatively charged. So what will happen is that the charge Q1 will attract the charge Q2, and both these charge Q1 and Q2 will start moving towards each other with some speed. but there is no external, force. There is no external force. There is no external force acting on charge Q1 and Q2. We know that when there is no external force acting on the system, by second law of motion, we know F is nothing, it's dp upon dt. When the external force acting on the system is zero, the total momentum of the system is conserved. So we can say that for a two charges which are separated by a distance r, if these two charges start attracting each other due to the mutual force of attraction, electrostatic force of attraction, that's the internal force between the charge Q1 and Q2, not the external force. We can say that the total momentum of the charge Q1 and Q2 will be always conserved. Suppose that after some time t, this charge has moved a distance x, and this charge is moving with, suppose, a velocity v1, and after some time t, this charge has moved some distance. Suppose this has moved x1 distance, and this has moved x2 distance, and this charge is moving towards charge 1, and this charge is moving with the speed of v2. And suppose these two charges are having the masses m1 and m2 respectively. We knew that the total momentum of the system must be conserved. Initially, the total momentum of the system was zero, and the final momentum, suppose if charge q1 is moving along the positive x-axis, we will take it as m1v1, and if charge q2 is moving along the negative direction of the x-axis, we'll take the moment of this charge q2 as m2v2. So this will be the final momentum. And this momentum must be also zero. The total momentum must also be zero, because initially there was no external force acting on the two charges q1 and q2. It's only because of their mutual interaction that these charges start moving with some speed towards each other, but still the total momentum of the system will be conserved, and the total momentum of the system will be zero. So this is the final momentum. So from here we will get m1v1 is equal to m2v2. That's the magnitude of the two momentums will be always equal. So if the charge 1 is going in this direction, q1, the charge q2 will be moving in this direction with the same momentum. Suppose this has momentum p1 in this direction, and this will have momentum p2 in this direction, right? So we can say that the p1 vector will be nothing, it will be equal to minus p2 vector. So this is the law of conservation of momentum, because of law of conservation of momentum. Or we can conclude that here in this system, linear momentum is conserved. Linear momentum is conserved. Now let's talk about another point. We know these two charges q1 and q2, these are separated by a distance of r, and we also know that the force acting between these two charges, because of the electrostatic force of interaction, it's directed along the line joining the two charges. Suppose that I choose a point P here, and I draw an axis which is passing through this point P and perpendicular to the line joining Q1 and Q2. It's passing through P, and perpendicular to line joining Q1 and Q2. Now, if I want to calculate the torque, we were discussing that suppose these two charges Q1 and Q2 are separated by a distance r, and we know the force of interaction between the charge Q1 and Q2 is directed along the line joining the two charges. And I'm drawing an axis which is passing through the point P and is perpendicular to the line joining Q1 and Q2, right? Now I want to calculate the torque because of this force F. What is that force F? That's nothing, electrostatic force of interaction. Torque because of this force on one of the charges. Torque because of this force on one of the charges. किसी एक चार्ज पे जो है मैं इस फोर्स की वजह से टॉर्क को कैलकुलेट करना चाहता हूं कि टॉर्क कितना है on one of the charges, and the force is directed along this direction, right? Like this. This is how the force between the two charges Q1 and Q2 is directed along the line joining the two charges. And torque, because of any force, we know it's nothing. It's the cross product of the R vector and the force vector, right? Where R is nothing. You can just write it like this. R cross F, it's nothing. RF sine of theta. Where R sine theta, we can also write it like this, R sine theta F. Or we can write it as R perpendicular into F. Where R perpendicular is nothing. It's the perpendicular distance between the line of action and the axis about which we have to calculate the torque. We can clearly see that this is the line of axis about which we have to calculate the torque. And this is the direction of force. This is the direction of force. And both these lines are joining. Both these lines are joining each other at some point. That point is P. Both these lines are joining at point P. We can clearly say that the distance, the perpendicular distance between the line of action, that is the line along which the force is acting on the particle, and the axis of rotation, it is 0. So the perpendicular distance between the axis of rotation and the force acting on this charged particle is 0. So we can clearly say that this R perpendicular is nothing, it's 0. So the torque acting on this on these two charges is 0. So there is no change in the momentum of the system. And one more point, the torque acting on the system because of this electrostatic force, it is always 0 on the charges. And one more point, we know that torque is nothing, it's also defined as rate of change of angular momentum, right? Rate of change of angular momentum. L is nothing, it's angular momentum. So if torque is 0, so it means that angular momentum is also constant. So in this case, L, that's angular momentum, is a conserved quantity. So here angular momentum is a conserved quantity. So these are the two important points with respect to the electrostatic force of interaction. It's a mutual force of interaction between the two charges. And if there is no external force acting on the two charges, the linear momentum of the system will be always conserved. And one more point, if the force because of this electrostatic force of interaction contributes do not contribute to the net torque on the system, and if the torque on the system is zero, the total angular momentum is conserved. The total angular momentum of a system is conserved. So total momentum of a system is a conserved quantity. Now let's discuss the vector form of a Coulombs law. Suppose that I have this Cartesian plane, yx plane. I'm placing charge q1 and charge q2 here. And suppose that the position of this charge q1 with respect to the origin of this Cartesian coordinate plane is given by this position vector r1. And the position vector of this charge q2 with respect to the origin of this Cartesian plane is given by position vector r2. And these two charges are separated by a displacement vector. Let's call this as a r vector. Let me call this r vector. The force on q2 is because of q1. There is a force on q2 because of q1, and there is also force on q1 because of q2. Let's suppose this is the force direction of force on q1 because of q2, and the direction of force on q2 because of q1 will be opposite. This is the force on q2 because of q1, right? And we know that in vectors the direction is given by the unit vectors, right? And let's suppose that unit vector along the line joining the two charges, let's suppose that's r cap. This is a unit vector along the line joining the two charges. Unit vector along the line joining the two charges. So unit vector will be because of this r vector. This is the unit vector of this r vector. And we know unit vector is nothing. It's r vector upon the magnitude of that r vector. That's how we define the unit vector. If this is the direction of r vector, then this is the direction of minus r vector. This is the direction of a minus r cap. Let's suppose that we are calculating the force on q1, F12. F12 will be given by we know that let's do it like this: r1 vector, r vector, and r2 vector. R1 vector and r vector are in the same sense. They are in the same order, r1 vector and the r vector. But r2 vector is in the reverse order. So according to triangle of vectors, r1 vector plus r vector will be nothing. It will be equal to r2 vector. So from here, we can write r vector as nothing. It's the r2 vector minus r1 vector. So this will be our r vector. Now the force acting on this charge q1, that's F12, it will be given by k q1 q2 upon r square, and the direction of this vector will be along r cap. The direction of this f12 is along the unit vector r cap. It's along the unit vector r cap. And r is nothing. It's mod of r vector. It's mod of r vector. So we can write it. R is mod of r vector. We can also write it like this. Mod of r2 vector minus r1 vector. Mod of r2 vector minus r1 vector. Now let's move on. We know r vector is nothing. It's the original vector that divided by the magnitude of that vector, r vector. We know r vector is nothing. It's r2 vector minus r vector upon mod of r2 minus r1. So we'll just substitute this r cap in the above equation. So f12 nothing, k q1 q2 mod of r2 vector minus r1 vector square into r cap vector. So it will be k q1 q2 upon r2 vector minus r1 vector, and r cap vector is given by r2 vector minus r1 vector, not the modulus. It's given by r2 vector minus r1 vector upon mod of r2 minus r1 vector. So we'll be left with force F vector, that's nothing, 1 upon 4 pi epsilon naught q1 q2 upon r2 minus r1 q into r2 minus r1 vector. So this is what we call as vector form of Coulombs law. This is nothing but vector form of Coulombs law. Coulombs law. We can similarly calculate the force acting on this charge q2 because of charge q1. Suppose in general, if we have to calculate the force between the two charges in general, using the vector form of Coulombs law. This is our y-x plane, and we have q1 charge here, we have q2 charge here. And we do not know about the directions along which directions the force is acting on the particles, on the charge particles. So what we will do is that, suppose we have been given that randomly, like we have r1 vector as the position vector of q1 charge and r2 vector as the position vector of q2 charge, right? Then we have to find the vector form of the force acting on these charges q1 q2. So what we'll do is that force on 1 because of 2 it will be nothing, because we do not know the direction of interaction between q1 and q2. What we'll do is that force on 1 because of 2 it will be nothing, 1 upon 4 pi epsilon naught q1 q2. We'll just calculate r1 vector minus r2 vector upon modulus of r1 vector minus r2 vector whole cube. And similarly, on 2 second charge, we will just calculate 1/4 pi epsilon naught q1 q2 will be r2 vector minus r1 vector upon modulus of r2 vector minus r1 vector whole cube. So this is the final equations that we'll be using as a vector form of Coulombs law to calculate the force of attraction between the two charges in the form of a vector. This final form of the Coulombs law, vector form of Coulombs law. Suppose that we have this question here. This is the question here. The question is a charge q1 equal to 2 microcoulomb is placed at a distance at a position coordinate दिया गया है 246 and another charge q of 3 microcoulomb charge b is placed at 122. These are the coordinates of charge b. Then find the force on a to b. q1 हमारे पास क्या है? It's given as 2 microcoulomb. तो उसके कोऑर्डिनेट्स क्या है? 246 और हमारे पास q2 चार्ज यहाँ पे ऑफ 3 माइक्रोकूलम्स और इसके कोऑर्डिनेट्स जो है दिए गए हैं 1 2 2. तो व्हाट डज इट मीन? इसका मतलब ये है कि जो हमारा r1 वेक्टर है, r1 वेक्टर, दिस इज नथिंग, इट इज 2i कैप प्लस 4j कैप प्लस 6k कैप. और हमारे पास r2 वेक्टर क्या है? i कैप प्लस 2j कैप प्लस 2k कैप. और हमारे पास चार्ज का मैग्नीट्यूड क्या है? 2 माइक्रोकूलम और 3 माइक्रोकूलम. So once again, we have to find the force on A due to B. Force on A due to B. Force on A due to B. So what we'll do is that we'll use the Coulomb's vector form of Coulomb's law. So force on A due to B. So it will be position vector of A minus position vector of B and modulus Q multiplied by the position vector of A minus position vector of B. So from here, we know 1/4 pi epsilon naught. This is the value of k. The value of k is nothing. It's 9 into 10 to the power 9 Newton meter square per coulomb square. You can just put the value here, 9 into 10 to the power 9. और हमारे पास चार्ज का वैल्यू क्या है? 2 microcoulomb, that's 10 to the power minus 6, और 3 microcoulomb, that's 3 into 10 to the power minus 6 upon हमारे पास RA vector minus RB vector, that is 2 minus 1, it will be I cap, and 4 minus 2, it will be plus 2j cap, and 6 minus 2, it will be once again 4k cap. इसका मॉडुलस कैलकुलेट करेंगे क्यूब and this vector I cap plus 2j cap plus 4k cap, and mod of I cap plus 2j cap plus 4k cap क्या होगा हमारे पास? That's the magnitude of this vector. When nothing, it will be under root of 1 square plus 2 square plus 4 square. That's 16 plus 4, that is 20 plus 1, that's under root of 21. So we'll get 9 to 3 to the 6, 6, 9, it will be 54 into base are same, powers will be added, minus 12 and 9, it will be 10 to the power minus 3. It will be here root 21, and we'll be left root 21 cube, and we'll be left with I cap plus 2j cap plus 4k cap. So this will be the final answer of the force between these two charges in the form of a vector. This is the vector form of force between these two charges. And that's it for today. Rest things we'll be discussing in the next class. Till then, goodbye.